Today, we're going to explore how we can take a bunch of data, like measurements of beautiful iris flowers, and use a powerful technique called Keyman's clustering to discover hidden patterns and group similar items together. Well, even see how we can simply complex data to visualize it easily. So, if you're curious about how machine learns to find orders in chaos, stick around. Supports all the necessary Python libraries for data manipulation, numerical operations, plotting, and machine learning. NumPy is for numerical operations, Pandas for data handling, though not excessively used here, matplotlib.plot, pyplot for creating visualizations, keymins for sklearn.cluster for performing keymins clustering, load underscore iris from sklearn.dataset to get the dataset, standard scalar from sklearn.preprocessing for data standardization, and PCA for sklearn.decomposition for dimensionally reduction. In this part, the famous iris dataset is loaded using load underscore iris open and close parentheses. The feature data measurements of the iris flowers is assigned to the variable x, and the true species labels, which are not used for clustering but we can be helpful for evaluation, are assigned to y. This section prepares the data for clustering by standardizing it. Standard scalar is initialized and then fit underscore transform open and close parentheses is called on X. This process scales the features so that they have a mean of 0 and the standard deviation of 1, which is crucial for algorithms like Keymans that are sensitive to feature scales. This section prepares the data for clustering by standardizing it. Standard scalar is initialized and then fit underscore transform open and close parentheses is called on X. This process scales the features so that they have a mean of 0 and the standard deviation of 1, which is crucial for algorithms like Keymans that are sensitive to feature scale. The K-means algorithm is applied to standardized data. A k underscore means model is created, specifying n underscore cluster equals 3 because the iris dataset is known to have 3 distinct species, and a random underscore state equals 42. Ensure reproducibility of the result. The fit open and close parentheses method then runs the clustering algorithms on the scaled data. After the Keyman's model has been trained, this part extracts the result. Keymans.labels underscore retrieves the cluster assignment for each data point, indicating which of the three clusters it belongs. Keymans.cluster underscore centers underscore gets the coordinates of the calculated centroids, the central points, for each of the three clusters in the original feature space. This section uses principal component analytics or the PCA to reduce the dimensionality of the data from its original four features to two principal components. This is done so the data can be easily visualized on the 2D plot. The PCA object is initialized with n underscore components equals to and then fit underscore transform open and close parentheses is used to apply the PCA to the scaled data x underscore scaled resulting n x underscore PCA. The cluster centroids are also transformed into this 2D PCA space using PCA PCA dot transform open and close parentheses. Finally, this section generates a scatter plot to visualize the clustering result. A figure is created and PLT dot scatter open and close parentheses is used twice. First, the plot of the data points in the 2D PCA space, colored according to their assigned cluster. C clusters, and then a second PLT that scatter open and close parentheses can plot the cluster centroids in red. Marked with X, the plot is given a title and X axis labels, and a legend is added to explain the different elements before being displayed.